Hello world, my name is Rahul and today we're going to be learning about neural nets. There are like million one machine learning models out there, but neural nets in particular have gotten really popular recently because of two things. That's our computers and more data. That help produce some amazing breakthroughs in everything from image recognition to generating our own art and music. There are really just three steps involved in machine learning. That's build it, train it, and test it. Once we build our model, we can train it against our input and output data to make it better and better at pattern recognition. A neural net is made of individual units known as neurons. Neurons are connected together through a synapse. Each neuron takes its inputs, then multiplies it with the weight of the synapse, and then returns the sum of the values. A neural net consists of multiple neurons arranged in the form of layers, where the output of one layer is the input to the next layer. So we have the input layer, the hidden layer, and the output layer. So input layer takes inputs, and the hidden layer refines the predictions and then forwards it to the output layer, where the output layer gives a final prediction. So let's build our own neural net. Okay, so let's start off by importing our NumPy library, which is a go-to library for scientific computation in Python. Then we'll create a function that will map any value to a value between 0 and 1. This is called a sigmoid function. This function will be executed in every neuron of a network when data hits it. It's useful for creating probabilities out of numbers. Once we've created that, let's initialize our dataset as a matrix. Each row is a different training example. Each column is a different neuron. So we have 4 training examples with 3 input neurons each. Then we'll create our output dataset. Since we'll be generating random numbers in a second, let's seed them to make them deterministic. Deterministic means that given random numbers are generated at the same starting point or seed. So then we'll hit the same sequence of generated numbers every time we run our program. This is useful for debugging purpose. Next, we'll create our synapse matrices. Synapses are the connections between each neuron in one layer or every neuron in the next layer. Since we have 3 layers in a network, we need to have the synapse matrices. Each synapse has a random weight assigned to it. After that, we'll begin the training code. We'll create a for loop that iterates over the training code to optimize a network for the given dataset. We'll start off by creating our first layer. It's just our input data. Now comes the prediction step. We'll perform matrix multiplication between each layer and its synapse. Then we'll run our sigmoid function on all the values in the matrix to create the next layer. The next layer contains a prediction of the output data. Then we do the same thing on the layer to get our next layer, which is a more refined prediction. So now that we have the prediction of the output layer and layer 2, let's compare it to the expected data using subtraction to get the error rate. We'll also want to print out the average error rate at a set interval to make sure it goes down every time. Next, we'll multiply our error rate by the result of our sigmoid function. The function is used to get the derivative of the output prediction from layer 2. This will give us a delta which we'll use to reduce the error rate of a prediction when we update our synapses every iteration. Then we'll want to see how much layer 1 contributed to the error in layer 2. This is called backpropagation. We'll get this error by multiplying layer 2's delta by synapses 1's transpose. Then we'll get layer 1's delta by multiplying its error by the result of our sigmoid function. The function is used to get the derivative of layer 1. Now that we have deltas for each of our layers, we can use them to update a synapse's weight to reduce the error rate more and more every iteration. This algorithm is called gradient descent. To do this, we'll just multiply each layer by a delta. Finally, let's print the predicted output.
Okay, so if you guys like the video, click on like and subscribe for more videos like this. And if you want to know more information about neural nets and everything, I have links down in the description and other things, so you can refer those for more information.